Let's just find the antiderivative of this function. We have the function to be 1 over the square root of x squared plus 1, and then the x squared plus 1 is raised to power 3. Okay, so whenever I see x squared plus 1 in the denominator, or let's say x squared plus a number in the denominator, I usually think of a trigonometry substitution, and in particular, tangent, right? So I will say let x be tangent of maybe some variable, let's say like theta. So that's the substitution I'm going to start off with. So I will say let x be tangent of theta. Okay, and when I do that, the next thing I'd like to do is to differentiate this. You know, we're going to check everything from the x variable to the theta variable. Okay, great. So to do that, I'll just say let's differentiate this and see what we have. So if we differentiate both sides, we're going to have the derivative of tangent of theta over the theta variable is going to be secant squared theta. So it's going to be secant squared theta, and then the over the theta, so we just put it down here. Okay, that's great. And now that we're done with that, I want you to know that if x is tangent of theta, right, we can make theta subject of formula here by taking tangent inverse of both sides. So this still tells us that theta can be rewritten as tangent inverse of x. And lastly, I want you to also note that if we have x to be tangent theta, what does that really mean? That means tangent of an angle theta is x, and not just x. You can also say it is x over 1. Right? For example, if you have a right angle triangle like this, and this is where the angle theta is being positioned, right? Tangent is opposite over adjacent, which means opposite is x, and I said x over 1. That means adjacent must be x. And what does that say about the hypotenuse side? The hypotenuse is going to be the sum of the squares of the other two sides, the square root of the sum of the squares of the other two sides, which means we're going to have 1 squared, which is just 1, plus x squared for the hypotenuse side. So we've gotten that. That tells us about tangent of theta. Okay, great. Now all these, we're going to put them back where necessary in this integrand, and then we're going to see what we get out from there. So let's say that this integral now becomes the integral of 1 over the square root of, now x squared plus 1, where x is tangent of theta. If you square that and you add 1 to it, it's going to become secant theta. That is so because we know that when you have tangent squared of an angle plus 1, this right here is just equal to secant squared of that same angle, just from trigonometric identities. Okay, great. So this is going to become secant squared of theta, and then we raise it to power 3. And then dx is just secant squared theta d theta. So that's just what we're going to replace, secant squared of theta d theta. Okay, great, that's nice. Now let's see how we can break this down. This is equal to, well, we can put this up there, secant squared of theta d theta. We divide that by, you notice this is secant squared and it is under the square root, which means they can cancel out, and we'll be left with secant to the third power of theta. So this is just going to be secant cube of theta. Great. Okay, so you notice this is of power 2 and this is of power 3. So after cancelling, only 1 will be left at the bottom. So we're going to have the integral of 1 over secant of theta, because some has been cancelled from the one in the top. Okay, great. So we have this. Looking at this integrand, 1 over secant theta is going to be cosine theta, because secant on its own is 1 over cosine, right? So that means we just have to find the antiderivative of the cosine theta over the theta variable. And this is quite easy, right? The derivative of sine theta is cosine theta. That means that the antiderivative of cosine theta will give us sine theta. And remember to add some arbitrary constant to that. So this is going to be sine theta and then plus c. All right? Okay, great. This seems nice, but this is not where we're going to stop, because we need to get back to the original variable, that is the x variable, by some sort of backward substitution. Okay, great. But then I've broken everything down to you, especially by the use of this right angle triangle, which is going to help us right now. So you notice this is sine theta. Let's continue over here. Sine theta, what is sine theta from this right angle triangle? If it says sine theta is going to be opposite over hypotenuse, that is just x over this, right? So that means this can become, sine theta is going to be x over that is just x over the square root of 1 plus x squared, and then you add an arbitrary constant to that. This is the antiderivative of that function. And if you'd like, you can also rewrite this in some other way. You write sine of This is theta. What is theta from here? Theta is tangent inverse of x. Tangent inverse of x. And then you close it, and then you add an arbitrary constant. This is also another way of representing. And now you choose this and this way. Which one do you think is more preferable? Well, I would choose this one, but you can decide also. Alright, thanks for watching. Subscribe to my channel.